Hello everyone, my name is Sato Sashimoto. My student ID is 169253446.
Hello, my name is Muhammad Ustan Arare Sulaiman. My name is 1692530.
My name is Davin Aryaditya Muktiwibawa with the student ID number of 169255342.
Hi, my name is Darren Adrian Permana. My student ID is 169255380, and we're from Group 3 from Class K84.
So, here are the group members. Okay, so for the problem introduction, we believe calculating using certain formula can take much time and not very efficient. We came up with a brilliant idea to simplify specific calculation like determining acceleration by looking for initial velocity and given final velocity. With this program, people can efficiently find out the acceleration without doing all the formula independently. Just put the data and the program will do the work.
And for this flowchart, we began with inputting the time in hours. Then we could input the distance in kilometers, and then we could calculate the initial velocity, which is v1, and later we could display the initial velocity in v1. And soon later we use for looping, and we ask, is the final velocity exist? If no, it's straight to the end, but if it answer yes, we could input the final velocity as v2, then input time for acceleration as t2, then finally we could calculate and display the acceleration a.
So for the computational thinking part, to get the acceleration result with the data of the time distance for the initial velocity, and we will ask the final velocity. If the user doesn't have any final velocity, then the output will say there is no acceleration to the program. So for example, here in the code I write, the time use the integer input, also the distance, and for the initial velocity I'm dividing the distance to time, and the output will be print integer the first velocity, which is final velocity, is velocity 1, and then the units, which is kilometer per hour. Okay, so and next for calculating acceleration, I will ask if it has velocity 2 or final velocity, and I'm using the input program. If the users say yes, then we can calculate the acceleration by by putting the data for final velocity in float, and the algorithm is acceleration velocity 2 minus velocity 1, or final velocity minus initial velocity divided by time, and then the output will be the data, and I'm here using the if else condition for looping. Okay, so let's start the program. Run. Okay, put this time in hours. This is just for example in 2 hours, and in kilometers is 100. Okay, so we get the first velocity or initial velocity. Is there any final velocity? If I say yes, then the program will ask for the final velocity. So let's say here is 3. For how many hours? 1 hour. Okay, so then we get the acceleration of the vehicle, which is minus 47 km per hour, and that's it. That's all for the program, and then we're gonna get into the results and analysis.
So based on the code that we've built, the result is we found that this code is very efficient and simple, but the drawbacks is we found that this code is its utility is limited, so we couldn't add more feature furthermore.
Okay, so for conclusion,
And the conclusion is our project shows how computational thinking can simplify physics calculation, especially for fine acceleration, by creating a program that automatically calculates acceleration from time, distance, and velocity. We save time and make the process more efficient. Though this tool is simple and has a limited use, it demonstrates how technology can make problem solving faster and easier in daily life. Thank you.
And then there's the individual contribution from Satoshi Hashimoto, the man himself, write down the code and create the slides. And then Darren Adrian brainstorms the idea and creates the flowchart. Davin Hussein help making the slides and finding out the idea. Me, I'm the team creative. And then Muhammad Wijdan backtesting the program. Well, that concludes our presentation for today. Uh, Thank you for watching.